Hello everybody. So this video is going to be a pretty quick one because this one is just on how to find the area of a regular polygon. And you'll see why in a second when I show you the formula, why it's paired with an isosceles triangle. Okay, so I'm going to kind of divide this into two parts. I'm going to show you an example with an isosceles triangle, and then I'm going to show you how this works with a regular polygon. Okay, so just like a right triangle, just like any triangle, okay? The area, oops, all right, my mouse is doing some craziness here. Okay, the area of any triangle is 1/2 base times height. Okay, that does not change, okay? So, but with an isosceles triangle, an important thing to note, slightly change my color here, okay, is that because you're dealing with an isosceles triangle, the height is going to cut the base in half. Okay, so my base is down here. So the height is going to cut the base in half. Okay, which can be useful, right, at times, okay? So let's look at an example here. Okay, so I'm going to draw this isosceles triangle right here. Okay, I'm going to tell you that this length is 12. I'm going to tell you that this degree measurement is 60. And I'm going to tell you that this height is 6√3. Okay. And then I need to know, obviously, what the base is, right, in order to find the area. Okay. So this is a situation where another situation where you might need to use either your knowledge of Pythagorean theorem, right, because we have two right triangles going on here, or your knowledge of special right triangles, because those two small triangles there are 30, 60, 90 triangles, or you can use your knowledge of trig in order to help you find out what these, like what this little like missing part would be. Right? Because it's got to be double on the other side, right? Because remember, the height here is going to cut the base in half. So whatever this value is here from this point to this point that I have marked in green, it's going to be the same on the other side. So I'm going to use my knowledge of special right triangles, but you could get this using trig as well. Using that knowledge, I know that this question mark value has to be 6. Okay? Again, you could get that with trig, you could get it with Pythagorean theorem, or you could get it with special right triangles. I'm not going to show you like the whole process that I use to get that, but if you'd like to know, send me a message and I'm happy to show you. Okay, so my question mark distance from here to here is 6, which means that my base, my base value has to be 12. Okay, so that means the area of my triangle is 1/2 base, which is 12, times, actually, I'm going to write this down here. Hold on. I'm going to run out of space here, so I'm going to write this a little further down. Okay, so my area here is 1/2 base, which is 12, times my height, which is 6√3. So what I'm going to do is just leave the √3 kind of off on its, like by itself, right? And deal with it at the end. So 12 times 6 divided by 2 is 36. Okay. So my area here is 36 with a √3 on the end. Okay, and I did not give you units in the problem, so you don't have to give me units in the answer. Okay, this is a slightly more advanced type, or like more like a challenge type problem that could get thrown at you. I just wanted to show you one where it's not just like they give you the base and they give you the height. I wanted to show you another way that you may have to use your knowledge of right triangles in order to solve for like a missing value, like a base or a height, right? Okay, so with that, let's jump into, I'm going to draw a little line here, how you find the area of a regular polygon. Okay, there are like large, complicated like formulas for this, but I think it's a little bit easier to think of these regular polygons as just shapes that are made up of a bunch of isosceles triangles, right? Because I could add a bunch more here, right? Here's another right triangle, another, right, etc., right? Okay. So if you can find the area of one of those isosceles triangles, then you can just multiply that area by the number of triangles you have, and that will give you the area of the regular polygon. Okay, so that's exactly what I'm going to do. Okay, so my general formula here, okay, and the number of triangles, by the way, will match the number of sides. So I'm basically just drawing like an imaginary isosceles triangle in here, finding the area of one of them, and then multiplying by the total number of triangles I have, which is the same as the number of sides. So the area of a regular polygon, which that's what this little symbol is right here. Now remember, a regular polygon is just any shape where all of the sides are the same length. Okay, so all of the sides have to be the same length. So my formula here is I'm going to do the number of sides times the area of one of those isosceles triangles. Okay, so I'm going to give you an example here. Okay, so in this problem down here, I'm going to tell you that the side length is 4. Okay, and then I'm going to tell you that this distance right here is 6. Okay, so the height of that isosceles triangle actually has a special name, which people use sometimes. So I want to make sure I at least tell you what it is. So this height of this isosceles triangle, which is also the distance from the middle of the shape to the side, like the edge, it's called an apothem. Okay, so no, I don't have a lisp. I'm not saying opossum with a lisp. It's apothem. That's actually like what it's called. But really, I want you to think of it as the height of one of these like imaginary isosceles triangles. Okay, so the area, I'm dealing with an octagon, right? Which means I have 8 sides. Okay, and I told you that one of the side lengths is 4, so that's like the base of my triangle, and I told you that the apothem, or the height of my imaginary triangle, is 6. Okay, so the area of one of those isosceles triangles is 1/2 of the base, which is 4, times the height, which is 6. 4 times 6 is 24. Cut that in half and you get 12. So that means the area of my regular polygon is the number of sides, which is 8, times the area of one of those triangles, which is 12. When you multiply all of that together, you get 96. And because I did not give you units in the problem, you do not have to give me units in the answer. All right, y'all. So that is it for isosceles triangles / regular polygons. If you would like more practice with problems like this, especially the regular polygon equation and the regular polygon problems, check out the practice problems video for regular polygons, right? So whichever video you're watching next, I'll see you in the next one. Bye, everybody.